All right, this is the assembly of the bearing onto the pinion shaft. Here's the pinion gear and the shafts going down through the plates here. I've got a pipe here, short pipe to bear against the inside of the bearing so the bearing's free to spin. Make sure you include this spacer. This is what sets the lash between the pinion and the ring gear. So this is from the factory. I found that I don't believe these are available from the dealer anymore, and I haven't found that you need them. So you just put it back together the way you took it apart. Everything works out. So anyways, we're gonna, this is also one I like to use the gauge on. So right now I'm pulling. You can see the gauge right here. You might not be able to read it, but it's reading about 700 psi, which is not that much for a press. And it's just sitting there, so I'm making nice progress. And the reason I'm watching all this is that if I see it pop up, now it's at 800, 900, because there's more surface that I'm pressing against. So as soon as I see that pop up, then I'm gonna know it's seated, and I don't wanna keep pressing. So I'm up to 1,000, because again, it should be going up. And I'm looking down, I got about a quarter of an inch left. Now it's popped up to that, right around 1,000. So that's perfect. I'm gonna watch it. And down to about a 1/16 of an inch. So right now I'm gonna start watching this gauge. It's at 1,100. Now it's popping up to 1,400, 1,500. So that thing's seated. That's it. Okay, we're gonna install the race for the forward taper bearing, which is about 4 inches down or so from the end of the housing, and right in here goes a roller bearing. You'll see that in a few minutes. So the race is in there. I've got a spacer, and sometimes what I like to do is use the old race that I pressed out, flip it over and use that to drive it in. So that's what I've done here. So I'm looking at the gauge, and here it's just kind of going along here. It's about 600, 700 psi. Just kind of, I'm going to watch that gauge, and when it starts to really kick up, then I'm going to know I'm seated. So it's about 600, 600. There it is, 600. Yep, there it goes. Now it's all the way to 800. And I'm all the way at 1,400, 1,400, 1,500. Ain't going anywhere. So that's it. It's seated. That's it. And the other one's the same way. You'll just flip the case over. It's a little more precarious, but same idea. All right, let's talk about the next step. So this is the pinion shaft, brand new bearings. This one's just sitting there, right? And the races are installed in the case. Just saw that. Now the next step is we have to put this whole assembly inside the case, tighten it down, the rear nut to the spec, which is 150, 160 foot-pounds, something like that. And then there's a spacer and a shim. So that goes right, contacts the bearing just like that, and then the shim is there, and then this bearing gets pressed on together. Okay, so this all gets pressed into the case together. This little shim is what determines the preload on this pair of opposing tapered bearings. These you can get from the dealer. I bought some before, but you might need them. But this is amazingly sensitive here. So last one I did, it was tight when I put it all together. So I needed to, no, wait a second. It was loose, that's right. It was a little loose. The preload, there's a spec that you'll see here in a bit, but it was loose. So you have to take it apart, and then it was loose, and it took 3/1000ths off this spacer with some fine 600 grit wet dry paper, and it nailed it right into spec. So depending on which way you have to go, you can always lap these to make it right. So what you're gonna see next is I'll get this all assembled. It's kind of tricky, you gotta get a pipe in here when it's in there, and then get the pinion supported because it's inside the case. And then you press that on. And then the next step after that, it's in the case at this point, you put this spacer in, and that's it. There's only just that spacer. And then you've got a roller bearing that you can only get these from the factory, from the dealer. And then that presses on top of that. Then you put the nut on there, get it all good, and then we'll take a reading on what the preload is and see if where we're at versus spec. So that's coming up. Okay, I put everything in the press, the pinion and the stack, everything I showed you just now. And then I pressed in the pinion into the bearings without the flange on, okay? Then I brought it back over the bench, put the flange on, and then just tightened down the nut just now until it got to the point where I'm ready to do it with a torque wrench. Got this set at spec. It's between 137, 150 something pounds. So, and I'll torque it. Let's check that one more time over here. Okay. And you can see here I made a little jig. You're gonna need something like this too. You can use, doesn't have to be like this. This was sitting around the shop, had a big hole in it, which was perfect to get access to that 27 millimeter nut. Then I just drilled holes around the companion, or around the flange here, so I could anchor it in. Then I just use C-clamps to get it on the bench, and it's a great thing because this thing does not move at all when you're trying to tighten things down. Okay, so there we go. Now what we need to check, this is kind of the moment of truth. We need to check the preload on the bearings. That doesn't feel too bad actually. But I can tell you, if it is good, I'm lucky, because normally I have to do 2-3 iterations here. I gotta tighten it down, it's too tight, then I gotta take it out and put in a thicker spacer. You can still get those at the dealer. And then if it's too loose, you can lap the spacer, make it a little thinner. And we're talking about total range between this thing not even being able to turn and being able to turn the way it is now is anywhere from 3 to 4 thousandths of an inch. So that's how sensitive this thing is. So if it's too loose, you're probably in luck. You won't need the spacer from the dealer. You can just take it out and lap it. If it's too tight, then you do need a thicker spacer to get those bearings further apart so they're not as tight. So we're going to check this. Let's see, move the camera a little bit here. And I've got a tool here that lets me do this. You don't need to use a specialty tool. And I'll show you in another little video clip what you can do with just a string and a weight. So I'm just turning it here. And it's sitting there at, let's see here. Let's do this. Let's do the preset here. So let's see here. Give me a second here. Okay, so that's about 10. Which is in spec. It's just a shade on the tighter side, but spec is like 7 to 11.5 or something like that. It's in the manual, but that's actually pretty good. I'm probably not going to mess with that. It's a skosh tight. That's it. And again, if this were too loose, you'd have to take it all apart, pull the shaft out, take that little spacer out. If it was too loose, then you'd have to lap 1,000th or 2,000th off, measure it with a mic, put it back in, and you can get right where you need. But this is it's about where you want it. This is with no seal installed, so, and none of the guts of this thing, so it's just a pinion installed in the case. So that feels pretty good. That's it. All right, I want to show you two ways you can measure the preload on a pinion shaft and a differential once you rebuild it, because it's important to get that set right. You've got a pair of tapered bearings in there that are opposed to one another, and you when you tighten the pinion shaft, the nut here down, there's a preload setting on these. This is a Nissan, this is the R200, and but I'm going to use this. This hasn't been rebuilt, but just for this demonstration here. So you could use a gauge, like something like that. These are expensive, and if you only use them once in a while, you don't really need the darn things, I don't think. So I've used this. I found this good deal on this, so I picked it up. But they're kind of hard to find where they can. This one reads 0 to 15 inch-pounds, so it's really precise and really low torque, which is perfect for this, because the spec on this is without seals and everything, after you rebuild it, is between I think it's 8 and 11 inch-pounds. So but I'm going to show you different methods. That's what you're seeing here. There's a stick, a little piece of plywood that's centered on this shaft and bolted on. This thing doesn't weigh anything, so it's not going to contribute to the spinning weight or the motive weight. So then I've got a 1 pound weight hanging on that string, and it's sitting on, so I've got this marked out from center line, 3 inch, 4, 5, 6, 7, 8 inches. So at 3 inches, you can see it's not enough force to turn that. So I'm going to go out to 4 right there. So that's 4 inch-pounds, still not enough. I'm going to go out to 5 inch-pounds, still not doing it. Going out to 6, and it's getting close. What I like to do is I'll tap it, I'll give it a little help, because it generally takes just a smidge more force to start something, a shaft spinning, than it does to keep it spinning. So I'm going to give it a little bump on the left side here and see if it goes. And it's still not going. So I'm at 6.5, and give it a little bump. There it goes. So there it is, 6.5 inches. So I got 6.5 inch-pounds is how much force it takes to spin that shaft. So I'm going to take this off. I'm going to measure it with the tool and compare the answers here. Okay, put it on the shaft. Set it to 0. Okay, it's zeroed, and then we just turn it. So as I'm turning this, it's wiggling around a little bit. I'm reading it. It's reading 6, 6.5, 6, 6.5, maybe a little bit more, 7, 6.5, 6, 6.5. So you can see the answers are not exactly the same, but no, I'm going to say it, they're the same. So the deal is with this is a great tool, very convenient, but you're depending on it being calibrated, and there's springs and other things in there that have to be calibrated, but it is convenient. This you don't have to calibrate. This is just basic physics. This is just right, as simple as that. It is so fundamental. A weight hanging out, a number of inches, that's the definition of torque, in this case, inch-pounds. So I just wanted to share that with you because this is free, and frankly, it's more accurate than just anything else you can do if you kind of follow my instruction. Particularly, give it a little nudge to get it started turning. That's what you're looking for. The other thing is, as it travels down, there's less distance from the center line, so it will stall. naturally. But just looking for that, it just starts to rotate, and that's your value. So in this case, 6.5 inch pins.